Hello everyone, welcome to the next part of this chapter. So today we're going to do a quadratic formula, solving the quadratic formula, and this is the harder version because it involves fractions. So you can see that this is what we call fractional algebra. And then so before you look at the QR codes to see how it's done, let me go through some of the main ideas. So what are we trying to do here, the strategy of solving something like this? So at the bottom line, you will know that eventually it's going to become a quadratic equal to 0, because I want to reach this stage so that I can use the quadratic formula to solve easily. So the question now is, how do I get from this fractional algebra looking thing to a quadratic formula? So the most obvious thing is there's no denominator over here and there's a denominator here. So what we need to do is to get rid of the denominator, because once the denominator is no more, it becomes a simple one line kind of thing with no fractions. So if you look at here, the method for this question is to do cross multiplication. So times over, you get this, and then you expand everything shift one side, you get the equal to 0. So that's the general strategy. So the getting rid of the denominator is the key. So that's here, eliminate the denominator. So for something like this is how you do it. You can see that there are multiple variations. So one type is like that, a fraction equal to fraction. The other type is a fraction plus or minus another fraction equal to 0. And then the third type is also a fraction plus or minus a fraction equal to a number that is not 0. So there are slight variations, and of course this will be the most difficult one, but generally the tactic is the same. So these two QR code will solve this too. So let me take some time and solve this instead. So our strategy here is to eliminate the denominator. So you notice that if I just move this whole fraction to the other side, I achieve something like this, right? A fraction equal to fraction. If you look on top, this is exactly the same pattern. So all you got to do is this one move to the right, and then I will do my cross multiplication to get this, expand everything, shift to one side equal to 0, solved. So you see, it's actually still quite simple. Okay, so this is something that you need to learn, because this is always coming out for exam for sure. Okay, so before we move on, I want to talk about some general philosophy kind of things. Okay, so there are a few ways of doing things. If you look at method 1 and method 2, these are the two general methods to solve a fractional algebra. So let's read this. So a single fraction on both sides, then do cross multiply. So in this case, you can see that using this as an example, you can do this. Okay, so clearly this is easier, but this won't always be doable, but this will be more stable. Okay, I'm going to do to combine these two fractions. So this is how we do it, and then I'm going to multiply this over, and because this happens to be 0, when I multiply this over, the whole thing becomes 0. So on the left side, I'm left with the numerator, right side is equal to 0. So if you compare these two methods, clearly this is easier, but this won't always work. So the philosophy here we're talking about is, are you the type that prefers to learn only one method that always works and give up using a method that's faster? So this trick of moving this over and then cross multiply is clearly faster, but don't always work. Whereas this method of always combining the fraction and then cross multiplying over will always work. Because if you look at this versus this, you notice I intentionally put it the same, just that it's equal to 2. If it's equal to 2, you cannot shift this over to the right and cross multiply, because there's 3 terms there. Instead, you need to combine these two fractions, and then this denominator you multiply over to achieve this. Then from here you expand everything, blah blah blah, shift to one side equal to 0, and then you use the formula. Okay, so this method over here is always going to work, whereas this is faster but only works sometimes. So something to think about. Now since we're on this, I want to show you how the best method, in my opinion, is. Okay, so I'm going to write down the exact same question down here to illustrate how I would have done it as a teacher. So instead of combining these two fractions, it requires a lot of steps, a lot of time, a lot of working. So the more advanced way is to actually multiply every single term by the common denominator. So in this case, the denominator is this and this, right? So every single term here, this, I'm going to multiply by this. It comes from where? It comes from these two. Okay, I multiply. So if you take this, you multiply this, you look at what happens. This basically cancels away. So I'm left with x times this, see? So in the same way, this multiplied by this whole thing, the x plus 5 is going to cancel. I'm left with 2 times this, but the negative is still here. And then this 2 times the whole thing is just 2 times everything. And then I'm going to multiply everything. Now this is similar to your primary school maths. In case you don't realize, let's say I do this. How would you combine this fraction? You will just make it 20, right? So imagine I give you like this. If I want to get rid of the 5 and the 4, I will everything times 20. 20 comes from where? 20 comes from 5 times 4. Just like here, you see. It's the same theory. And once I times 20, the 5 and the 20 cancels, become 4. The 4 and the 20 cancels, become 3 times 5. And then the x and the 20 become 20x. So you see, we are doing the exact same thing in primary school. Maths has not changed. So hope you have learned something from especially this part of the video. Okay, so before we end the video today, I'm going to go through some of the more weird looking questions, so which I feel are a bit tricky. So I'm going to spend some time going through. So if you look at this question, the average lousy student is going to, oh, okay, the two denominator times together. But again, you're not using your brain and you're not thinking. Look carefully. This is x minus 2 times x minus 2. Over here is x minus 2. If you look at this logically, do you need to times together? No. This fraction over here is fine. Over here, you are just short of an x minus 2. That's why you see that this fraction over here, I do not touch it at all. Whereas this one is short of x minus 2. So I times x minus 2 numerator, denominator. And then at this moment, this 2 is already the same denominator. I'm just going to times over. And then the numerator will be here minus here. Done. And then since I'm on here, one of the biggest thing that you Sec 3s cannot do is because Sec 2 you never do your work. You don't know how to expand this. Okay? This is actually using this a minus b bracket square is equal to a square minus 2ab plus b square. This is special identities. I expand like that. And then, you know, I do the normal things. I achieve the equal to 0, quadratic equation, use the calculator app, solved. Okay. The other question I want to go through before we end the video will be this one. So the question used to be like this, right? But what you don't realize is actually there's an over 1 over here. Okay, there's an over 1. So in this case, I see it as two fractions. I'm going to shift this fraction to the right to achieve this, and then I'm going to so-called cross multiply, and then I achieve this, and then you know, and by now you know the drill. Expand everything, shift to the left, equals 0 is the formula, blah blah blah. Okay, so this is the whole chapter. So with this, you should start doing homework 1. So hope you've learned something. Thank you and bye bye.